Well, hello everybody. Let me show you what you missed just the other day. I, of course, looked at their assignment, gave them back their homework quizzes, because we will have a quiz coming up next class. So you need to make sure that you know how to graph those parabolas and those lines, tell me where the intersection is, and then you have to make sure you understand how to solve those systems of equations that we just did last class. Tell me where they intersect, and then tell me how to make something drop out. Well, here's what we missed today. I did push the quiz off till next time because we're going to go over word problems today. Overall, once you get past the fact that there are words in them, they're really pretty easy. So, if you will, look at your example sheet, and let's just attack these as number one. It says an individual can buy 3 apples and 5 oranges for $7. At the same store, might be Dillon's, might be Walmart, 7 apples and 11 oranges cost $15.70. We're going to find the cost of each. Here's how we're going to start these. Off on the left side of your paper, let me get some ink here. Off on the left side of your paper, we're going to tell what we're going to be working with. So I'm going to come over here and let X represent the cost of an apple. And I'm going to let Y represent the cost of an orange. You can use any letters that you want. If you wanted to use A for apple and O for orange, that's okay also. On this video, I'm just going to stick with X's and Y's. Well, here goes. I can buy 3 apples and 5 oranges for $7. So it's going to look like this. 3X, that shows me the cost of 3 apples, plus 5 oranges, shows me the cost of 5 oranges. I know that is $7. I also know I could get 7 apples and 11 oranges for $15.70. Hey, now it's no longer a word problem. You do whatever you want to do to solve this, just like we did last time. I can't turn a 3 into a 7, and I can't turn a 5 into an 11. So I might multiply the top equation by 7, and I might multiply this bottom equation by -3. And the reason I was thinking that gives me 21x, that gives me -21x, so that's going to help us solve it. So now let's distribute just like we did last class. I've got 21x plus 35y equal 49. And I've got -21x minus 33y equal -4710. And remember, if we've done a good job, something should drop out once we're done. In this case, my x's drop out. I'm left with positive 2y equal positive 190. I'm just adding those in my head. I'm going to divide both sides by 2. And I'm going to get y to be 0.95. Hey, we need to make sure our answers make sense today. I got the variable y. If you come over here and look at what it stands for the cost of an orange. So 95 cents for an orange. That's pretty legit. But I still need my x value. So just like we did last time, I'm going to plug 0.95 right in there. Or in the top, that part doesn't matter. I'm going to go 7x plus 11 times 0.95 equal 1570. And we're going to solve that for x. Once I solve that for x, I got x to be 0.75. But I'm not done yet. I call this next step dummy proofing it. I'm not going to look back to see what your x represents and your y represents, or your A represents and your O represents. So I'm going to get rid of this. This next stage I call dummy proofing it. We come over here and make sure that anybody that walked through the doors will know what our answer is. So I'm going to come over here and say apples cost, and then apples was our x, 0.75, or 75 cents, however you would like to write it. And I'm going to put oranges cost, 0.95 or 95 cents. Here's my answer. I call this dummy proof 'em. That way anybody that looks at your paper knows what it's talking about. They don't have to hunt around to say, well, what's this Y stand for? Oh, it's cost of an orange. So there it is all in one place. But that's what it's going to look like. Here goes my next one. It says, I recently opened my piggy bank, which contained only nickels and quarters. I deposited 153 coins that had a value of $25.05. How many of each coin did I have? I'm going to come over here once again, and I need to let X and Y represent something. So I'm going to let X represent the number of nickels that I have, and I'm going to let Y represent the number of quarters that I have. So there's my setup. I'm going to come back and use that here in a little bit when I dummy proof it. Hey, I have two things going on here. I have 153 coins, and I have a value of $25.05. Well, here's how my setup's going to look. I have nickels and quarters. So here's what it's going to look like. My number of nickels, which I'm calling X, plus the number of quarters that I have, which I'm calling Y, is 153 coins. Now I have to put some money into it. Every nickel that I have is worth, well, duh, a nickel. But as a decimal, that's 0.05. So I'm going to have 0.05x plus every quarter that I have is worth 0.25y, and I have a total of $25.05. Let me point out something while I'm here. 0.05 is a money amount. 0.25 is a money amount, so this 2505 better be a money amount. If it's not, something's not right. Hey, don't be afraid because there's a decimal involved. Our goal is to still make something drop out. So I'm going to multiply this top equation by negative 0.05. The reason I'm going to do that, these x's are then going to drop out. So let me distribute, and I'll just write that down here. So I'm going to have 0.05x minus 0.05y equal, negative 7.65. The bottom equation I'm leaving alone. 0.05x plus 0.25y equal 25.05. I'm going to add them up, and I forgot my negative right there. I'm going to add them up, and my x's in this case are going to drop out. Now I'm going to take negative 0.05 plus 0.25, and I'm going to get 0.20y equal, and I'm going to add these two items together and get 1740. I'm going to divide both sides by 0.20. So I'm going to get y to be 87. Now we can work hard or not hard here. I know y is 87, and I can plug this wherever I want. Watch where I'm going to plug this. I'm going to plug it right there. Because to get x by itself, x is going to be 153 minus 87, which is 66. So I know that x must be 66. Hey, now when I dummy proof it, x, when I come back over here and look, x represents the number of nickels. So I'm going to tell the world that I must have 66 nickels, and I must have 87 quarters. If you put n equals 66, I think you're going to represent knuckles. Now that'd be with a K. And if you let Q equal 87, we might think that represents quell. So you got to spell that out. Last year I made them write sentences for this, so I'm trying to be a little nicer this year. So make sure it's dummy proof for us. So there's 2 down. And you can always pause the video, replay it, backtrack it. Here's your number 3. While I opened my piggy bank, Mr. Leo cleaned out his wallet. He found 89, $5, and $20 bills. If they totaled $820, how many of each did he have? Well, I got to come over here and start. I need to let X represent something and Y represent something. Well, what's he got in his wallet? He's got some $5 bills and some $20 bills. So I'm going to let X represent the number of 5s that Mr. Leo has, and I'm going to let Y represent the number of 20s. So there's that part of it. Some things I know. I've got 89 total bills, and they have a value of $820. So my setup, the number of 5s that I have, plus the number of 20s that I have, is a total of 89 bills. I'll show you in a second what would happen if I flip those around. Now let's put money to it. Every $5 bill that I have is worth 5x. Every $20 bill is worth 20y. The total amount of money I have, 820. Just like a while ago, 5 is a money amount, 20 is a money amount, so 820 better be a money amount. If you flip these around, then it wouldn't make sense, because 89 is not a money amount in this case. And then I hope solving it's the easy part now for you. I'm going to multiply the top by -5, and then I'm going to distribute. So I've got -5x minus 5y equal -445. And the bottom equation I'm leaving alone. Notice that when I add, the x's are out of there, just what I want. -5 and 20 make 15y equal 375. Divide both sides by 15. So y is going to be 25. I need my x value, so I'm going to plug this way right there, because then that means x is going to be 89 minus 25, which is going to be 64. So x is 64. Time to dummy proof it. What does x stand for? X represents the number of 5s, so I'm going to have, we have 64 $5 bills, and I'm going to have 25 $20 bills. Notice that I put the money amount on the 5 and the 10, or the 5 and the 20. So 3 down, 1 more to go. But that's all there are of these, guys. Read through it, label it, set it up, solve it. Here's the last one. 7,500 tickets are sold for a concert. Floor seats sold for $18 and balcony seats sold for $11. If a total of 107,035 was taken in, how many of each ticket was sold? I'm going to come over here and let X represent something and Y represent something. X is going to represent my number of floor seats. And Y is going to represent my number of balcony seats. So there I got those labeled. Here comes my equation. The number of floor seats that I have plus the number of balcony seats I have, I know that's a total of 7,500 tickets or seats. Now let me put some money into it. Floor seats cost $18. balcony seats cost $11, and we brought in a total of $107,035. So there's my setup. I've said it 3 times in a row, or 2 times in a row, so I'll say it one more time. 18 is money, 11 is money, so that better be a money number. Solving is going to be the easy part now, guys. I'm going to multiply the top by negative 18. So I can go, I'll write it down here, negative 18x minus 18y equal, oh boy, negative 135,000. And the bottom equation I'm just going to leave alone. If I add, something better drop out, of course, so the x's drop out. So I've got negative 7y equal negative 27,965. I'm going to divide both sides by negative 7. So in this case, my y value is going to be 3,995. I'm going to plug this right there, because then x is 7,500 minus 3,995 for a total of 3,505. Here comes the dummy proof of it. I have 3,505. Now match up your x over here, floor seats. And I had 3,995 balcony seats. Since these represent seats and not money, don't put a dollar sign by it, because those aren't money. That represents the number of seats. Okay? That's all there is to the lesson. You should have a worksheet to do with 8 or 9 problems on there. And then remember, we'll have a quiz next class. Good luck to you.